Greetings, my name is Beatrix, and today, in the STEM project, I'd like to present to you the cycle of uranium through the thermonuclear industry. I'll use drawings and schematics for it, but without further ado, let us begin. Firstly, we'll talk about the raw material, the extraction of uranium ores in mining areas known as anomalies, which get these names specifically for the higher concentrations of uranium. Later on, the ore is grinded and goes through chemical dissociation from other materials, becoming a dust of U3O8, known as yellow cake mass. The yellow cake, formed like U3O8, is then converted into UF6, uranium hexafluoride, a salt that is easily converted into gas at low temperatures. This gas is most necessary for its next step in process, which is the enrichment of uranium. In it, uranium hexafluoride is centrifuged. The lightest and most desired isotope of uranium, 235, is elevated, and the most present and dense, 138, descends. Since the concentration of the isotope increases very slowly to reach the ideal H ratio, it must pass through a series of centrifuges, known as the ultracentrifuge cascades. The next process is known as reconversion, where uranium hexafluoride is reconverted into uranium dioxide. In it, it goes through a series of chemical transformations. Firstly, the uranium hexafluoride is turned into uranyl ammonium tricarbonate when it's vaporized and introduced to CO2 and NH3. Then, the uranyl ammonium tricarbonate is turned into uranium dioxide when heated in an oven and put in contact with water vapor. It liberates N2 and air, and it's homogenized to UO2 powder. This uranium dioxide is then arranged in pellets. They are known as green pellets after being combined with other uranium compounds during the press, and are known as sintered pellets after being heated to 1750 Celsius to get into the ideal state for fission circumstances. The pellets are then assembled into zirconium-based alloys called zircaloy, which are then arranged in beams and put in place inside the reactors. For the power generation, the uranium within the beams initiates the process of nuclear fission, where the bonds between protons and neutrons are broken when unstable, disintegrating into more stable nuclei. The breakdown liberates gamma radiation and mainly the heat necessary for the thermonuclear process. Inside the reactor, water pressured at 157 times the atmospheric pressure is heated by the core to 320 Celsius. The heat exchange between this water vapor and the second circuit, which is the coolant system, turns in a turbine, thus generating kinetic energy to be converted into electric energy. But it's not only used in turbines, but also to stabilize the system, ensuring the safety of the plant and its surroundings. After this, the alloys are greatly contaminated with gamma radiation, and thus need to be separated by its destinations depending on its radioactive levels. The lowest level ones are placed in sheds or deposits to dissipate the radiation, while the highest grades undergo processing and packaging to be stored for long periods of time in protocol. And that is the end of the video. I hope you have enjoyed, and many thanks for watching this video. Don't forget to check the sources and keep creative and inventive.